Now let's talk about linear combinations of sine and cosine with addition and scalar multiplication. Linear combinations means multiple of one plus multiple of the other. So suppose we have 3 sine x plus 2 cosine x, and want to add to that square root of 2 sine x minus 5 cosine x. So that's 3 plus root 2 sine of x minus 3 cosine of x. And if we want to multiply an expression like this by a scalar, let's say e squared times 3 sine of x plus 2 cosine of x, then we just get 3e squared sine of x plus 2e squared cosine of x. Now, for any linear combination of sine and cosine you can think of, its opposite is also a real linear combination, if the coefficients were real to begin with. So to subtract a sine of x plus b cosine of x, we can add negative a sine of x minus b cosine of x. If a and b are real, so are negative a and negative b. Furthermore, if we try that, let's say 3/2 sine x minus square root of 2 over 6 cosine x, and we add the opposite, plus minus 3 over 2 sine of x plus square root of 2 over 6 cosine of x, then we get 0 sine of x plus 0 cosine of x. So we have this zero linear combination of sine x and cosine of x also. And if we have a1 sine of x plus b1 cosine of x, and we want to add a2 sine of x plus b2 cosine of x, and a3 sine of x plus b3 cosine of x, we could do this in any order because we're basically just adding coefficients of sine and coefficients of cosine separately, and we could also put parentheses somewhere if we wanted. So we could write a1 plus a2 in parentheses plus a3 sine x plus b1 plus b2 in parentheses plus b3 cosine of x, or we could do it differently. We could switch the order of the first two and then put parentheses around the second two. So we could say a2 sine of x plus b2 cosine of x plus parentheses a1 sine of x plus b1 cosine of x plus a3 sine of x plus b3 cosine of x. We get the same thing, basically because what we're doing is adding coefficients of sine x and coefficients of cosine x separately, and these coefficients are real numbers, and therefore they're going to obey the usual rules of multiplication and addition of real numbers. Actually, the sine x and the cosine x are just placeholders, aren't they? Because if we're adding, we don't ever do anything with them except remember where the coefficient of sine x is and the coefficient of cosine x is. So this is just like adding in R2 pairs of real numbers, because we're basically saying A1 comma B1 plus A2 comma B2 plus A3 comma B3. Right? And when we're done doing the addition, then we're going to put the sine x back in its place and the cosine x back in its place. But all the work we're doing is really on the coefficients. And even if we do scalar multiplication, k a1 sine x plus b1 cosine of x is k a1 sine of x plus k b2 cosine of x. So it's just like saying k a1 b1 equals k a1 comma k b1. The end.